Yeah, which actually I think it led you to writing this book, The Programmer's Brain, and the
Yeah.
subtitle is called What Every Programmer Needs to Know About Cognition. Maybe can you share the reason why you actually have interest to write this book and actually write it in the first place?
Yeah, I think this was a book that I wish had existed when I was struggling so much with learning and teaching. Because it's sad that in computer science curricula in university, but also in boot camps and in high school curricula, there isn't this course about how people learn stuff. Which, as you see in my book also, it might seem like a little bit far away from programming, but there's so many areas in which people that are programming need to know a little bit about understanding, not just because they're teaching, and even professionals are teaching because they might be onboarding, but not even if you're teaching, if you're trying to learn something yourself, it is very useful if you know how your brain works. But also in writing code, someone else will have to read this code. And we always talk about, yeah, you want to have readable codes, right? This is something we value. And we have this really nice frameworks like code smells. Code smells are not readable. But why? What are the underlying cognitive principles? Because code smells, I have a whole chapter about them. I love code smells. Half of my PhD thesis was about code smells. But you have to understand why code smells are smelly. Because otherwise you get these situations like, oh, we don't want to have a long method. So all our methods are no longer than 5 lines. Yeah, why? Well, this is in Fowler's book. So understanding what makes code readable from a cognitive perspective will help you design better user interfaces, better APIs, better libraries, just better code bases that are easier for people to get onboarded into. So there's so many areas of programming where knowing something about knowing is just going to make you happier and more effective. It is a surprise that this doesn't really exist. And it's also hard, like there are many introductory cognitive science books, so you can have access to that information. But then if it's not contextualized to programming at all, then why would programmers read that? It isn't very clear what the benefit is, what I'm going to gain if I learn this. So I thought, well, maybe it's good if we have a book that is a little bit of introductory cognitive science and then a lot about what that means for programming, for different aspects of programming, like design patterns and naming and code smells and onboarding, like all the stuff I talk about in the book.
And you mentioned in the beginning, it's interesting for me, right? The fact that you said programming is one of the most demanding cognitive activities. Maybe you can compare it with some other demanding cognitive activities. And then the second question will be, what does that imply for us as a programmer to actually maybe prepare us physically or maybe mentally or even like part of our brain or diet or maybe something like that?
For sure. That's a lovely question, by the way. So, of course, everyone will say that our work is hardest, right? I'm sure that house painters say that their work is the hardest and nurses say that their work is the most demanding. So you have to take this with a grain of sand coming from a computer science professor saying, oh, programming is hard. So I have to start with that disclaimer. But what I think makes programming so hard is if we compare it to writing nonfiction, writing an essay or writing a letter in which you want to convince someone, I think those are at the same level of hard. You have a solution in mind, you have a plan. These are going to be my 5 arguments that I use to make my case. However, then programming adds this extra layer of you cannot freely express your thoughts. I was just before this interview writing a column for a magazine that I write a monthly column for, and I can freely switch over to paragraphs. Word is not going to tell me, oh, no, you cannot switch those paragraphs because you make an argument in the second one that you only started in the first one. So now there's an error, right? So at one point, programming is about these big ideas, classes and methods and user interfaces and calls to the database. But at the same time, every change you make has to be in this very constrained form of the syntax has to be correct. And in some languages, depending on your language of choice, the type system has an opinion about what you're doing. So you have to translate these very high level ideas into very, very specific forms. And it's very hard. We talk a little bit about it in the book as well. Programming languages are not made as means of thinking. Like languages, as I said, if you're just writing fiction or non-fiction, you can make sentences that are incorrect. For now, I can just put a placeholder that's half finished. And I can save my Word document in that form. And then the next day I come back and I can fix it. But it's hard to save code that isn't like compiling because this is maybe I don't want to commit this form of my code. Well, yesterday I was like committing code in which tests were still failing. And then I feel a bit like dirty, right? I don't want to be in this situation, but I had to finish because the day was ending. So I think that is what makes programming hard. You have to have both big ideas and plans, but you have to do that while fighting with the syntax, the compiler, the transpiler, and in many cases, type systems and other details. So that switching of mental modes is just really hard.
So yeah, related to my second question is, when programmers understand about the cognitive demand of this job, yes, then you will need to understand how the brain works in order to be much more effective, more performant as a programmer. So what should we do actually as a programmer to actually first be conscious about it and do something about it?
That's again a great question. So there's a bunch of things that you can do. The book has many exercises that people can try. One thing I think is important to realize is that syntax might be more important than we think. So we have this culture in programming in which we explicitly tell each other and also novices that syntax doesn't matter. You can just Google the syntax. It is all about logic. You can look everything up on the internet, or your compiler will teach you. There's very much this understream of that a compiler can be a teacher to kids, right? Oh, if they make a mistake, then you get an error message that will be informative and very clear. And then the kid or the programmer knows what to do. So we told each other that syntax knowledge is irrelevant. This is interesting because this is at a certain level true. Like I am now learning Rust, coming from a background in C# and in Python. And I can express some of my ideas half-assed, and then I Google for the Rust syntax and I get there. So this is true at a certain level, but for beginners, it is not all that true. It is a bit like rich people saying money is not so important. Yes, it's not so important if you have a little bit of money, but if you have no money, it is very important. So I think this is something we underestimate, that if you don't know the basics of a language, then it takes so much energy and effort to find the syntax that you're not going to be productive. Even in languages you know really well, if there's a few syntax concepts that you have to look up every time you're spending time and energy switching to Stack Overflow, Googling, figuring out what you need, just a little bit of syntax practice is going to go a long way. So that's something I think people discount because practice is boring. We don't want to do boring stuff in programming or cool stuff. And programming certainly is more fun than drilling syntax. And I make a more elaborate case, of course, in the book. Doing syntax is actually a very effective way to make yourself a more effective programmer.